Welcome back. So in the previous lessons, we explained everything about random forests. We saw how we can implement them, and we saw how we can compare our implementation with the sklearn implementation. Now, let's discuss what are the pros and the cons of random forests, or basically the bagging algorithms in general, right? So the random forests are robust to outliers, and we know this because we are using resampling with replacement, right? So if we have outliers in our dataset, then most of the parallel models or most of the machine learning models that we are going to use, or the decision trees we are going to build, will not really have outliers in their data, right? So outliers will be there, but most of the machine learning models will not see these outliers. And when we take the average of the machine learning models or the machine learning outputs, then these outliers will have very small effect on the output, right? So this is the first pro or the first advantage of using random forests. And second, random forests actually works very well with nonlinear data. So if you have nonlinear data, you can use random forests without any hesitation. And we saw that also random forests have lower risk of overfitting than decision trees, right? Because decision trees, if you build the complete tree, we said that we might have a chance of overfitting, and then we discussed the pruning and how we can do the pre-pruning by just stopping at the maximum depth, or post-pruning by having alpha and all this, right? But with random forests, we don't really need to do all this, right? Of course, you can have pre-pruning and maximum and post-pruning for the decision trees that you are using, but you don't really need to do this because random forests by themselves have lower risk of overfitting, and we explained this in the previous lessons, right? And random forests also runs efficiently on a large dataset because we are training parallel models, right? And each model is working, yes, on the complete dataset, but with repetition, right? Or with duplication. So if you can train, so instead of training many decision trees sequentially, you are training them in parallel, and each decision tree is actually a subtree and not a complete tree, right? So it will run efficiently on a large dataset. So these are the advantages of using random forests. So what are the cons or the problems with decision trees with random forests? First, the main problem is that it will be biased while dealing with categorical variables, and we saw this is a problem in the decision trees, and it's the same problem for random forests. We didn't really introduce anything to solve this problem. And the second problem with random forest is that it can be slow in training. So how come we are saying here that it runs efficiently on a large dataset, and here we are saying it has slow training, or the training is slow? Basically, if you are training random forests on one processor, right, you are not doing any optimization, or you are not parallelizing the data and parallelizing the models, then the training will for sure be slow, right? But if you are training the random forests on multiple processors and you are making sure that you are optimizing your code, so you are parallelizing the training, then the training will not be slow. So we should say here slow training if the code is not optimized, right? And this is very important. And it's not suitable for linear methods with a lot of sparse features. So if we have categorical features, right, or we have even numerical features, and most of these numerical features have very little values or have zeros in their values, then random forests will not actually work that well, okay? And finally, the random forests are greedy algorithms, just like decision trees, right? And they will not yield the global optimum tree structure or random forest structure, but it will give you very good results, right? You need to know that most of the machine learning algorithms are basically greedy, right? We cannot guarantee that this is the optimum solution or this is the best solution we can get, but this is the best solution we can get right now with this data, with this model, and that's it, right? We don't really have any mathematical proof that this is the best solution, okay? It's based on trial and error. You need to optimize the hyperparameters and tune the hyperparameters, so you cannot really say that this is the best possible solution using random forest, right? But as I told you, most of the machine learning algorithms have this problem. Okay, so this is a summary for the pros and cons of the random forests. In the next lesson, we will start introducing boosting and see one of the examples for boosting, which is AdaBoost. Okay, so let's go to the next lesson.